Okay, so let's apply what we just learned in the past two snippets. The first challenge, sort of, we're going to have is this maze. We made this maze, and we can imagine this small icon being our robot, and we would like to navigate this robot sort of in this pattern in order to reach this bottom point. So for a second, think about how we could use code, these coding blocks, in order to navigate this robot to this end destination. Now that you've had a second to conceptualize the way you would go about solving this problem, I will give my solution and my take on getting this icon from point A to point B, and then later translating it in the real world with the robots that we have built. So, assuming each box on this piece of paper represents one rotation on our EV3 programming application, we can identify this entire movement of going forward to be one unique direction. So what this would look like on our code would be simply moving forward two rotations, right? Then we need to identify the next point. The next point is making the turn to actually get in the direction to make this straight line. Let's identify this as its own separate important part. The final part that we would take is this final straight route in order for us to get to this end destination, making it so that we only have 3 blocks that we will need to use in order to get here. So what would this look like in the EV3 coding software? Well, by using the same examples that we used earlier, we know that we need to go straight for 2 blocks. We obviously would like to continue using rotations, and since we're going straight, we can use our direction to be 0 once again. And I would generally suggest using a power of 75. That's what the default application suggests. And since we were under the assumption that each rotation represents each box on the piece of paper or the maze, then we can simply say that we would go for 2 rotations. And as usual, we would end with a break. Now the second step is the turn, as I stated earlier. Now once more, we will use rotations, and we need to realize that the turn we are making is a right turn. So that means that we should use a positive value of 50. And as I stated earlier, a good value for turning is generally around 25. And a 90-degree turn with the bot that we've made is generally made by 1 rotation. And then once more, we will conclude with a break. So now that leaves us with only 1 more box to go through on the maze, and that means that we can simply set our rotation to be 1 once again. And since we're just going forward and we're using the same power structure that we've been using, we can just leave this to be 0 and the power to be 75, and we need to end with our break. So if we were to run this program, which we will get into later, then we would be able to navigate through this maze properly. I just like to move over the blocks if I already know that there's going to be a certain amount of steps that are going to be needed. So the first step we identified was to go forward. So I'm just going to go ahead and input the values. And again, the great part is that this software will always remember that 75 is the default value. So a lot of the time, you won't have to change that. Okay, so next we have to remember that we need to make a right turn. So we can just change that to 50, and staying with the theme of low power and 1 rotation for a 90-degree turn. And finally, to conclude with going in a straight line, we will be able to simply keep these values because we only need to go for 1 rotation. So
what looked like a very complicated problem was able to be tackled with 3 very simple blocks. Now we just export.